Assalamualaikum and hi. Welcome to our presentation on coastal erosion monitoring using remote sensing. We are Group 5 from class RAS2564A and this is our group members. YASMIN binti ABDUL RAZAK, YASMIN binti TALIB, SYAZREEN binti NORULHISHAM, and SABRINA binti SHAMSUDIN. In this slide, let me introduce you what is coastal erosion. Coastal erosion is a natural process where shoreline materials are gradually worn away by the actions of waves, tides, and currents. This process has serious consequences, including loss of land, destruction of infrastructure, and disruption to ecosystems. In Malaysia, erosion is made worse by rising sea levels, storms, and human activities such as construction and deforestation. There are some challenges in traditional monitoring. Traditionally, monitoring erosions involves field surveys or aerial photography. However, these methods are time-consuming, expensive, and often limited in spatial and temporal coverage. They also depend heavily on good weather conditions and making it difficult to collect frequent and accurate data, especially in rapidly changing or remote coastal zones. Here are some benefits of remote sensing. Remote sensing provides a solution to many of these challenges. It allows us to observe large areas of the coastline repeatedly over time, providing valuable multi-temporal data. It's especially useful in areas that are difficult to access. When combined with GIS and field validation, it gives us powerful tools for monitoring, analysis, and planning. For satellite platforms overview, in this study, we use two key satellite platforms, which is Sentinel-1 and Sentinel-2 from the European Space Agency. Sentinel-1 uses radar sensors that can collect data day or night in all weather. In Sentinel-2, it captures high-resolution optical image across 13 spectral bands, which helps identify shoreline features and vegetation changes. In previous studies also, they used Landsat 8 and Spot 6 for long-term shoreline analysis.
Next, Malaysia Erosion Challenge. Malaysia has a coastline of over 4,600 km. Many areas are under threat from coastal erosion, including Selangor, Langkawi, and Johor. For example, a study found that more than 51% of the Selangor coastline had been eroded between 1990 and 2050. This highlights the need for regular and reliable shoreline monitoring. To tackle the challenge, we need reliable tools, and this is where satellite technology comes in. Here for Satellite A, we use Sentinel-2, which is a multispectral optical satellite that captures images at 10, 20, and 60 meter resolution, depending on the spectral band. It includes 13 spectral bands covering visible, near-infrared, and shortwave infrared region. It has 5-day revisit cycle and a 12-bit radiometric resolution, making it ideal for detecting subtle changes in shoreline features and vegetation. When Sentinel-2 focuses on optical data, we also need radar data to see through cloud, and that's where Sentinel-1 plays its role. Sentinel-1 is equipped with SAR, which collect data regardless for weather or lighting. This makes it perfect for Malaysian tropical climate, which is often cloudy. It offers resolution from 10 to 40 meter and operate on a 6 to 12 day revisit cycle. With a 16-bit radiometric resolution, it can detect detailed surface changes such as erosion in mangrove or wetlands. Now, let's see why traditional monitoring alone is not enough. Malaysia continues to face serious threat from coastal erosion, put ecosystem and infrastructure at risk. Traditional monitoring methods are limited by cost, time, accessibility, and weather. They are also not ideal for detecting subtle or slow erosion. To make informed decision, we need accurate and up-to-date shoreline information.
Satellite-based monitoring approach. To solve these issues, we propose a satellite-based approach using Sentinel-1 and Sentinel-2. Sentinel-2 captures optical data for shoreline features, while Sentinel-1 uses radar to collect data regardless of weather. Combined with GIS, this system helps us analyze erosion patterns over time. Accuracy is improved by validating the results with GPS field surveys. Key spectral characteristics. Spectral bands helps us separate land, water, and vegetation. Sentinel-2 uses visible bands for natural color image and near-infrared band for vegetation analysis. Shortwave infrared bands detect soil moisture and highlight erosion-prone areas. Sentinel-1 uses SAR to detect changes in surface roughness and wave activity even during cloudy conditions. Data processing techniques. We applied the Normalized Diffuse Water Index or NDWI to enhance water features in imaging. The formula is green minus NIR divided by green plus NIR. We also use the maximum likelihood classification algorithm to categorize land and water pixels. On-screen digitizing was used for manual shoreline tracing and validation. Study area and satellite data. Our study areas included Pulau Toba in Langkawi and Sarata coastlines in Selangor and Johor. We used Sentinel-1 and Sentinel-2 data from the years 2016 and 2019. Images were downloaded from Copernicus Open Access Hub and chosen based on their quality and coverage. Pre-processing of satellite data. Before analysis, all satellite images were pre-processed. This included radiometric correction to reduce sensor noise, geometric correction to align image, and orthorectification using the UTM zone 47N. For Sentinel-1, terrain correction was performed using ESA Snaps software. Detecting shorelines. To extract the shoreline, we applied NDWI to Sentinel-2 image to enhance the boundary between land and water. Then, we used maximum likelihood classification to automatically classify pixels. On-screen digitizing was used to manually verify and improve shoreline edges, ensuring greater accuracy.
Detecting erosion over time. We compared shoreline position from 2016 and 2019 to measure how much erosion or exhaustion occurred. Erosion rates were calculated in meters per year. We also conducted land use and land cover analysis, which revealed that urban development and deforestation contribute significantly to shoreline retreat. Accuracy check validation. To confirm the accuracy of our data, we compared the satellite-derived shorelines with GPS rapid static survey data from the Johor Strait. The results shown an average positional accuracy of 1.4 meters. This proves that satellite-based monitoring is a reliable and cost-effective method. Study result. Our results show that Pulau Toba experienced the highest erosion rate of 4.39 meters per year. We also observed that human activities, especially deforestation and urban growth, directly increase erosion risk. The satellite-based approach proved both accurate and practical for long-term coastal monitoring. In conclusion, remote sensing is an effective method for monitoring coastal erosion in Malaysia. Sentinel-1 and Sentinel-2 provide consistent, high-resolution data that works in all weather conditions. Combined with GIS, these methods support early detection, better planning and sustainable coastal management. Thank you for watching our presentation. We hope this study helps highlight the importance of satellite technology in managing Malaysia coastal challenge.